Batch, ETL, streaming, ELT, bridging. There's all kinds of ways that we work and transform data in our data pipelines. And there's traditionally been two approaches to this. Either you go and write a bespoke program to do all of the connectivity and transformation and stuff like that, or you opt into a heavyweight stream processing tool, a stateful stream processor like Apache Flink or Spark or things like that. But I want to give you another alternative approach that gives you a lot of the operational simplicity and the scale without it being overly complex or a burden to maintain. And I'm talking about mixing two technologies that are two of my favorite open source projects, NATS and Benthos. And so in today's episode, we're going to be diving into 4 practical use cases on how to do stream and data processing using NATS and Benthos. We'll go over what Benthos is and why I think NATS plus Benthos is just such an amazing pairing for your data processing needs. So let's get into it. But before we do, please be sure to hit that subscribe button. It's good to know that you're subscribed and I can get to know more about how to deliver awesome content to you. All right, let's dive straight into NATS and Benthos. So as I mentioned before, NATS and Benthos is just a match made in heaven. So we're going to talk about what Benthos is. It's this little guy over here, this blobfish, has an amazing logo, and we're going to talk about why it's so good with NATS. So first off, what is Benthos? Well, Benthos is a very simple, stateless stream processing tool that basically boils down to this in terms of architecture. On one side, you have sources. This could be something like Kafka or Kinesis, and it could even be, NATS, HTTP. There's lots of different, things on the source side that you can configure. And then you have sinks, things like Elasticsearch or Kafka or NATS or any of these other kind of cloud services. And Benthos supports a lot of sources and sinks, which is awesome. And in the middle here, you have all sorts of different stuff. Usually when you're bridging two technologies together, it's not like you just kind of take, one end of the input and connect it to the other end. There's usually some form of transformation or filtering that you're going to want to do in the meantime, which is why Benthos has this really awesome data pipeline processing layer that you can do transformations, enrichments, and hydration. And this leads to kind of a very, very simple architecture where Benthos really doesn't need to store any state about what it's doing. It can remain completely stateless, so you can horizontally scale these things however you'd like, because it's really leaning on the sources and sinks and even some of its processors in order to do the job of storing state, which is actually really great because NATS essentially does that with Jetstream. So what makes Benthos so cool? Well, it's built as a self-contained Go binary, so it's very easy to either grab a container image of it or just download it onto your computer and run it, throw it wherever you want to. It runs great at the edge. It also gives you this configuration-based stream processing. So rather than writing code and compiling it and deploying it, you're really just setting up a set of YAML configs in order to do this. And it makes for some really, really tight, small configs to do some really complicated things, which I really love. The other thing I really love is that Benthos is stateless, like I mentioned before. It does have this transactional model where, it makes sure that the message is, in fact, delivered to the sink from the source. And I'll explain a little bit about how that transaction model works. But at the end of the day, it is stateless. It leans on other systems to provide state, whether that is state on the source side, on the sink side, or even intermediate state. It has a ton of supported sources and sinks, so if you want to be able to pull things out of a cloud provider and put it into NATS or another kind of technology, they don't even also have to kind of work the same way in terms of paradigms. Benthos supports kind of ETL type pipelines as well as batch, streams, things like that, and it's really a good way to start taking a bunch of different styles of storing data and pull them out into more of a streaming workflow. And like I said, it pairs perfectly with NATS. So why does it pair perfectly with NATS? Well, if you were to think about the architecture a little bit more in depth here, you can have Jetstream, whether it's a stream or a KV, end up on either the source or the sink side, and then you could also have things like NATS KV store some intermediate state. So you can really start operating these things not just in terms of bridging two, different message queues together or two different technologies together, but you could even use this in between your jet streams as logic to kind of transform or enrich, filter, hydrate your data for caches and stuff like that. And Benthos is not going to be holding on to any state in its process. Instead, it can defer to things like a KV, which is obviously like consistent, and we can have multiple folks, writing to that KV. And we're going to show a lot of really cool examples of how we could take advantage of this. But the fact that you can kind of have like NATS and Jetstream be your communication layer as well as your persistence layer, and then you can just run as many Benthoses as you need to for scale, really makes for an interesting kind of processing pipeline where you're not babysitting like a Flink cluster or anything like that. You're not deploying, actual code. You're really just using this configuration-based, data processing pipeline, and being able to scale it almost infinitely is just really, really cool. And so we're going to be diving in to what all of that looks like. So I came up with kind of 4 patterns that we'll cover today, and like always, I'm going to be writing this code alongside with you. There might be some where I'll copy paste just because it'll make for a better video, but all of this code is available in a GitHub repository in the link below, so you can feel free to follow along. This stuff is really easy to set up and configure. There's a bit of a learning curve to all the different components that exist in Benthos, but it takes about a day or so to really get it. And then, you're kind of off to the races, and you could the sky is your limit here. But we're going to cover like 4 basic patterns that I think are really, really useful in a lot of kind of data processing applications. And we'll write them and we'll experience them together, and then I will send you off to go write some more Benthos. So the first one is bridging. This is just a simple idea of connecting one technology to another. In our case, we're going to be doing Kinesis to NATS, and we'll even do some S3 to NATS. We'll do some enrichment, some analytics pipelines, and then we'll kind of close it off with like, how do we do some like tiered storage or backups and restore? So let's first cover bridging. So this is a really simple example, but I think it's a very, very common use case, which is like I want to be able to get data out of one system and into NATS Jetstream or into NATS somehow. Or maybe you want to take some data out of NATS and put it into another system. This is where Benthos is going to be coming really in handy with its bridging aspect. So I don't really have to say too much about this. I mean, we have Kinesis on one side and we have Jetstream on the other side, and it sends messages and Jetstream receives messages. Now, there's different paradigms with how these two technologies can work, and you can use Benthos to kind of tweak or transform your message before it arrives. For instance, we won't do this in the example, but for instance, let's say you're kind of picking off of a Kinesis shard, and you want to be able to pull something out of its payload and use that as a subject inside a Jetstream, so you get all of that really nice, fun indexing. Well, you'll be able to do that with Benthos very, very easily. So let's dive into the code for bridging, and we'll just write this example together. Okay, so I have my terminal open right here, and I do have Benthos installed. You can install Benthos just by going to Benthos.dev, the website, but Benthos is just a simple little Go binary that I could, run, and it takes config files and has all kinds of really fun stuff here. But one of the things I really love about Benthos is how fast and fluid it is to be able to develop in it, which is why I'm showing this to you today. It's very reminiscent of, using NATS and the NATS CLI, where you can just kind of play with it and tweak things until you got stuff working. And rather than us writing a data pipeline in days or weeks, we're really doing this in minutes or hours. And so let's walk through what it looks like to connect AWS Kinesis over to a NATS Jetstream. So bear in mind, let's call this a bridge.yaml. So Benthos configs are all YAML based, meaning we're going to write YAML. You can also write stuff like Q, which eventually outputs to YAML. But the general gist of how it works is you have your source, which is going to be called an input, and you have all your configuration that lives inside of that input. And then you have your output, which is your sink, and you could configure whatever you want there. And then you have your data processing pipeline, which is just specified a pipeline. That pipeline has processors in it, which is just an array of different processors. And so you don't need to know everything up front here, but that's just kind of the general gist of what a Benthos config looks like. So let's start with our input. When you put no output, the output is going to be standard out, which is great because it makes for some really good play. So I'm going to specify AWS Kinesis as my input, and I need to pick what streams I want to be listening to. This could be specific shards. It could also be an entire stream. So I have one in my AWS account called ratings. And then I need to pick the AWS region that I belong to, which is US East 1 for this one. And then because Kinesis doesn't really store the cursor or the offset for a particular consumer, we need some place to store that. And so I've already set up a DynamoDB table inside of my AWS account that's going to be used to store that cursor or that offset. So I'm just going to say the table is ratings sequence. And that's pretty much all that we need in order to set up Kinesis. So I'm going to go ahead and save this. And then I'm going to down here run Benthos. I'm going to say Benthos, specify the config, and use bridge.yaml. And I'm also going to say use environment variables for my env. Now this is just keeping my AWS profile and stuff in there. I don't want to expose that to anybody. So so if you're following along, you will need to have AWS Kinesis set up with some data in it, with a DynamoDB table. If you already have one of those lying around, go ahead and follow along. But I'm going to go ahead and run this. And what it's going to do is it's actually going to start outputting messages from Kinesis. And as you can see, we are now starting to fetch messages to Kinesis, and we are actually just outputting them to standard out, which is great. Now I'm going to go ahead and delete that cursor that was just set in DynamoDB so we can actually hook this up to NATS. Okay, so that cursor's been cleared, so we can start reading from the beginning again. But before we do, let's make sure we specify the output to be NATS Jetstream. Now, the cool part about this is this all supports, using credentials and security and everything like that. But I'm just running a local NAT server here right now. So I'm going to specify that the URLs that I want Benthos to connect to NATS from is just the default, which is localhost 4222, as always. And then I get to pick which subject I want to publish every event from. So I'm just going to say ratings. Now I need a stream that's going to be listening to this subject. So let's go ahead and say NATS stream create. And I'm going to say the subjects are ratings, and then just use the default for everything else. And then let's name this stream ratings. Okay, so we have a ratings stream. And now we can go ahead and run that bridge, that Benthos command one more time. And it should be outputting stuff to NATS Jetstream. So we've run it, and in this case, now that we're outputting to NATS Jetstream instead of standard out, silence is golden here. So it's not really going to log anything unless I, put the logger in trace mode or something like that. But what we can do is we can say NATS sub, we're going to say stream ratings. And you can see that we're already getting data kind of feeding in there, which is great. NATS list, or NATS stream list. We have 123,000 events coming into the ratings. And by the way, these are movie ratings. We're going to continue with all of our examples, and we're eventually going to end up having an analytics pipeline that's going to kind of average out these ratings on a per movie basis, which is pretty cool. But just to let you know what these payloads kind of look like, we have a customer ID in here. We have an ID for the actual rating event itself. We have a media ID and the rating and timestamp. And so imagine that these are coming in maybe from some sort of front end where people are rating movies, and we want to be able to kind of like decorate this data, find the media that it's available from, maybe find the customer and do some sort of analytics-y thing from it. But we're finished with step one. In just a few lines of YAML, about 11, we have hooked up Kinesis to NATS Jetstream, and we can just leave this running and it will just keep feeding events from Kinesis into Jetstream, which is awesome. The other cool part about this is if either one of these things are offline, Benthos has a really great transactional model to make sure that it can reasonably recover and make sure that messages aren't dropped, which is really, really cool. All right, so let's move on to our next example. Enrichment. So a basic enrichment workflow is, really just right here, where we might want to be getting data from somewhere, and we want to run it through a pipeline, and before it ends up in its destination or its sink, we want to reach out to another kind of service to get data so we can decorate the payload with it. So in this case, what we're going to do is we need to find all of the media that we're talking about. Now, thankfully, these payloads that just came in from the ratings Kinesis stream, they do have IMDb IDs associated with them, which is great because we're going to be using those. And we also have a CSV that lives inside of Amazon S3 that we could also use to get more information about our movies. And so that's exactly what we're going to do. Just to add on to our data processing pipeline for a minute, We're going to do a little bit of ETL, where we're going to be pulling objects from an object store, S3. We have a media CSV. We're going to be parsing that CSV into various messages. Then we're going to be looking up that stuff from IMDb and adding it to the payload, and then we're going to throw it in a Jetstream KV. I know that sounds like a lot, but we're going to write that right now. It's actually not too bad in terms of code. Okay, well, first things first, let's create another file. I'm just going to call this Enrichment.yaml, and we'll go ahead and close out this old pipeline just for now. And here we're going to be setting an input of AWS S3. And just like before, we will set a region of US East 1. And we need to specify a bucket that we want to read from, code gangsta media. There we go. And so this is going to be pulling all of the files from the bucket, and we need to chunk them up like they're a CSV. So we need to split these things on lines, and we need to parse the headers, and we need to parse the CSV. That sounds like a lot, but actually Benthos comes built in with all of this stuff. So I can just say scanner CSV. And there we go. I have all the defaults for CSV, so that's why I have the curly braces here, but you can specify custom delimiters, stuff like that. And you don't even have to do CSV. There's lots of different ways you can kind of pull data out and extract it in an ETL-like workflow. So that's our input right now. Let's actually kind of just run this and see how it works out. So again, we're going to run Benthos, but this time we're just going to run Enrichment.yaml, and we'll keep our env here. And I'm going to hit run on this. And you can see it's pulling out and just sending these messages over to standard out. And then it closes. And that's because this is actually like a bounded stream. It's going to read all the files. And when it's done reading the files, it's just going to close itself out. You can set it up to just run indefinitely and listen to notifications on SNS when buckets are updated. But in our case, we might just want to run this as like a batch job or an ETL job. The cool thing about Benthos is you can mix and match those different data processing paradigms. And so we have some information that's coming in from that S3 bucket. But one thing I'm really missing that I want to use eventually is I want to know what the poster is from IMDb. And so I need to use a API call to the OMDB API to get more information about that media before I stick it into a key value store of some sort. I don't want to have to look up that poster every time, especially since I have an API key that has a rate limit and stuff like that. So it's probably good that I do that before I put it into a key value store. So this is where we're going to be making use of our pipeline. So I'm going to go ahead and say pipeline and processors. And I can specify an HTTP processor here that's going to make an HTTP call, take the result, and then I get to map it back onto the payload before it ends up in the KV processor, which is awesome. So the other thing that I want to do here is since we're making HTTP calls, we want to kind of run some of this stuff concurrently. So I'm just going to say threads 12. And then I'm going to go ahead and use what's called a branch processor. Now, this branch processor is kind of like it sounds. If we were to look back at this example, this is kind of going out of bound to look up something from IMDb, and then it's getting back to us, and then we want to choose how we want to map it onto the payload. So we don't want it in the main path, but we want it to branch off and eventually come back to us. And so that's why we use a branch, and I'll show you in just a second. We're going to do a branch has its own set of processors. And the one that we want to use is the HTTP processor, and we just want to specify a URL. Now I'm going to copy and paste this because I also have this in my .env, but we want to make a call to the OMDB API. Now, one thing that's really interesting here is that Benthos supports string interpolation. So I can just pull off the IMDb ID from the payload and put it in there. And I can also use an environment variable, my API key, to specify that API key here. And so we're just going to be making a quick HTTP call over here, and we want to take the result and map it back onto the payload. The way that we do that is inside of this branch processor, we can say result map. And we can use a little bit of bloblang. Now, bloblang is a mapping language that was designed for Benthos. You can use other types of mappings and stuff like that, like JavaScript and awk and stuff like that. But bloblang is really, really powerful and definitely worth learning because it has really good integration with Benthos as a whole. But really all that it is I could just say, you know, this thing on this side equals this thing on the other side. In my case, I want to create a new field on the payload for each message. So I'm going to say omdb result, and I could just say this. And that's going to give me the payload for the omdb result. Now, I know for a fact that these are going to return a payload that has all of its keys capitalized, which is against my sensibility. So I'm going to just do a little bit more mapping here. I'm going to say map each of the keys, and I just want to slugify them. So that's just going to downcase them. Going to, you know, if there's any spaces, it will put a dash in there. That's just going to make them a little bit more pretty and a little bit more uniform with the rest of my payloads. So I can go ahead and run this. And I'm just going to run it for a little bit just so we can see what the payloads look like. Let's go ahead and do that. Okay. So now we're getting much more stuff from our payloads here. You could see that we do in fact get our poster image, which is exactly what I wanted. So we're getting a lot more information here for each of these movies. And I can actually do one more thing, which would be, let's go ahead and say mapping this dot format JSON. I'll run this again. And you can see now we're kind of having a nice pretty print of all of this. But we're getting a lot more information for each of these movies, which is awesome. And so we get our poster, which is exactly what I wanted. And I just want to take this whole payload for each message, including the OMDB result, and I just want to put it into a NATS KV. So let's go ahead and do that. I'm going to specify an output. And I want to say that this output is a NATS key value store or bucket. And we're going to specify our URLs, which again, we're looking at localhost 4222. And we want to get a bucket called media, which I need to create. And we want to specify where what key we want to put each of these values into. And this is where we're going to be using our kind of string interpolation for Benthos. And we're just going to pick off the ID that exists on the payload. Again, this stuff is all really easy to do. Pick things off of payloads, put them into keys, stuff like that. So before I run this, let's go ahead and do NATS KV add media. There we go. We now have a media KV. And we can now just start running this and seeing how it works out. Okay, so no errors, silence is golden. Let's do a NATS KV watch media and see what's going on here. Wow, we're getting a lot of stuff flowing through here. So what this is doing is it's going through about 6,000 movies, and it's parallelizing a lot of the HTTP calls that it's making, and it's getting results back from the OMDB API, and then it's sticking that into a NATS KV, which we can watch in real time. So imagine having a workflow where maybe this isn't running as a job, but it's running, in real time with notifications, and every time a movie gets updated, we're getting results for that, which is just really, really cool. And so again, another example of being able to kind of like enrich the data, but also do a little bit of ETL, a little bit of transformation, stuff like that, all in very, very few lines of code. I mean, we're up to now 22 lines of YAML, and we did a little bit of mapping, we did a little bit of HTTP calls, and it's all very kind of solid and reliable, which is so nice. So we're going to take this example and we're going to iterate on it, and we're going to do something a little bit more complicated. But let's jump into the next use case. Okay, this one's the big boy, analytics pipeline. And so one of the things I wanted to show is that you don't always need to have a big stateful stream processor in order to do a lot of work. When I've been learning about what folks are using to kind of glue a lot of these kind of processes together and create the data that they want, of course there are the really big data, terabytes and terabytes, that need to be processed and done in a stateful manner. And I'm not talking about those payloads, but I'm talking more about workloads that are going to be lightweight analytics pipelines. And so Benthos does support some lightweight system clock windowing. It also supports this idea of kind of like intermediate state, or using a processor to kind of cache things. And that's essentially what we're going to be doing today. Is we're going to be using a lot of the stuff that we've already built, and we're going to turn that into an analytics pipeline. And so here's what we got. Now, we already have this jet stream for ratings that we've created from AWS Kinesis. And we also have this KV of media where we can go and get, a specific piece of media, get some information about it. Maybe it's poster image, stuff like that. And then I already have in a background kind of a SQLite database that has information about customers. And here's what we're going to do. We want to start picking off things from this ratings jet stream. And we want to look up the media in the KV, look up the customer from a SQL database, and then we want to update a new key value store called media ratings that's going to include stuff like the title, the poster, and then the count of ratings and the average of all of those ratings for a particular piece of media. And so we're going to have more stuff come in than what actually comes out. And the cool part about this is we can scale this to as many Benthoses as we need. And the reason is because we're not actually going to be hitting any contention on this key value store. There's actually two ways to do that. One is to partition on the source side, which is what we're not doing. We're just using a plain old jet stream. The other one is to use optimistic concurrency control to make sure writers don't overwrite each other, even if they're processing review or a rating from the same piece of media. They're going to be kind of going into single file order to update that stuff. And so again, this seems like a really complicated thing, but we're going to do it. We're going to, I'll probably copy paste some code, but we're going to do most of it right now. All right, let's try it out. So I'm going to go ahead and create a file called analytics.yaml. And we're going to start with our input. Our input is easy. We're going to specify NATS jetstream as our input, and we're going to say URLs, like always, is NATS localhost 4222, and we want to look at the ratings subject. And this is just going to bind to a stream that matches that ratings subject. Next up, we're going to be doing a lot of really interesting stuff in the pipeline. This is where I'm going to start copying and pasting stuff. We do want to up our thread count to 12 in this case, and then we want to start specifying our processors. And we're going to do three things here. The first one is we're going to look up our customer from the SQLite database. So the way this looks is we are going to do a branch like we did before, because remember we want to branch out and then eventually write our stuff back to our payload. And we're going to do a SQL select using SQLite. I have a database DB in my working directory that's already there. We're just going to do a select star from customers just to get the customers. And the customer ID already exists on the payload, so that's going to be totally fine to map that over. This seems like a lot, but don't worry, there's tons of documentation on this, and I don't need to explain how to use SQL necessarily. The other interesting bit here is even after we do the branch, we're not going to be mapping this result back to the payload. Instead, we're just going to set it as metadata. So metadata allows us to kind of reach in and reuse this object somewhere, but it's not going to futz with the actual payload of the message that's going through Benthos at this time. And so, so we're going to be picking off ratings, and we're going to be looking up the customer so that we can use it later. All right, let's move on to our next processor, which is looking up the actual media from that media KV. A lot of this is going to look really similar to the SQL processor. We're going to branch things out, but instead of SQL, we're going to specify NATS KV, and we want to do a get operation on the media bucket with the media ID. Remember, we just stuffed this stuff in a bucket so we can, use this, and then we're going to say we're going to map it to the metadata of media. Okay, and here's the last one, and this is actually the coolest one. Now, this one's a little bit more advanced, but I wrote what's called a template for Benthos that allows us to kind of have a bit of an abstraction. And so you notice that we have this processor called NATS KV update. I'm going to look this up right now. This is called a template, and it's basically a composition of a lot of different processors. But all this thing is doing is it's getting a value from the key value store. It is attempting to mutate it and then write it back. But the interesting thing is we're using our optimistic concurrency control to make sure that clients, who are processing the same rating from a media or the same media in general are not stomping on each other. And so they'll kind of do a single file line and make sure that their updates apply sequentially like that. And so we're going to just use this. So we have our URLs pointing to our NAT server. We have the media ratings bucket, which I need to make. We're also using that metadata media ID as the key. And then here's the interesting bit. We're going to do a mutation where we set the title, we set the poster, we set an average. If it doesn't exist, we'll set it to 0. Same thing with count. And then we'll also upgrade or update our average and our count by just doing kind of a very quick rolling average calculation. And what this is going to result in is we're going to be able to output media ratings into this KV store that can be watched, can be used, that will be a really, really cool tool for us maybe inside of an analytics dashboard. And so that's kind of the update on what we want to do on the NATS side. The last little bit here is, since we're outputting all this stuff to a NATS KV processor, we still need to specify an output, but it's basically saying, hey, if anything's errored, then make sure you knack on the NATS side so we can do any sort of retries. This, once again, is a really cool way to lean on NATS for things like retries instead of making Benthos really complicated and stateless. Benthos can stay pretty consistent. So I know this is a lot of stuff. The example is in the repo, but this is still only 50 lines of code for really, not trivial, not necessarily the most complex, but not a trivial analytics use case. And so I'm going to go ahead and write this out. And let's go ahead and try to run this analytics workflow. But before we do, let's create that, that media ratings KV bucket. Okay, we have our media ratings KV bucket. And let's go ahead and run that Benthos command. We're going to call this analytics.yaml. And since I have that template, I'm going to need to specify that one as well. Let's go ahead and run this. Okay, so it looks like this is running. Let's go ahead and say NATS KV watch media ratings. Let's see what we get. So we're getting a bunch of info here, which is really, really cool. And it looks like we've processed all of the data, but we could just keep this running and it can process all this data in real time as more stuff comes in from Kinesis. But as you can see, we have an average that's calculated. We have the count of the number of reviews. We have a poster and we have the title. Now, one of the really neat things about all this is a NATS KV, so we could do gets on these, we could do watches on these. In fact, let's go look up one of my favorite TV shows, Seinfeld. I'm going to say NATS KV watch media ratings, and I'm just going to specify this ID. And you can see that we have an average of 3.7. We have a count of 19. We get the poster, so we could reasonably put this in an analytics dashboard. The other thing that we could do is, if I go ahead and rerun this, you can actually see all the times Seinfeld gets re-updated. And so the average changes because it gets recalculated, the count changes, and this is all happening inside of Benthos, and using NATS as kind of that way to store and move state around. And it's again using kind of intermediate state as well inside of that media. And so all of this kind of stuff this data is moving around and transforming and changing and reacting to each other, and it's because Benthos and NATS are working in tandem with one another. So that's a more complicated use case, but I hope you're able to wrap your head around that. You could do some really cool stream processing stuff with this. Okay, our last use case, and it's a bit simpler than what we just went over, but this one's also really cool and fun, is what if you wanted to do backups? Now, Jetstream does have a backup mechanism, but there's also other ways that you can do backups. Maybe you do have an S3 bucket that you want to store these messages in because they're going to expire, or maybe they have some TTLs on the Jetstream side, and you just want to archive this stuff. But you don't want to just, send it message by message over to S3. That's going to be really inefficient. So what we want to do is we want to batch these things into groups of like 10,000. Let's say we want to compress them, tar them, compress them, and send them off to S3. And just as well, we can actually do the opposite way, where we could pull these things back from S3, uncompress them, untar them, and turn them back into messages again. And this is the beauty of using something like Benthos and NATS together. So let's go ahead and do that. I'm going to create a file called backup.yaml. And we're going to specify an input of NATS Jetstream. I'm just going to paste this over. We have our URLs. We have the rating subject. I'm just specifying maxac pending. We can just set this to 10,000, not 11,000. And then we're just going to go ahead and say our output is going to be to S3. Okay, we have Code Gangsta Backups as our bucket. We're using US East 1 as our region. We get to specify a path, and so I'm using a timestamp here. Again, this is all using blobling. There's tons of really cool functions that you could use that are super useful for transforming data. And then lastly, I mentioned that Benthos can kind of go in and out between multiple paradigms, whether that's ETL or batch or stream. And so in this case, we're going from a streaming paradigm into more of a batching paradigm. And so we're going to batch these things into batches of 1,000. Then we're going to tar and gzip it. And we're going to put it on S3. And so this one's amazing to me that this works the way it does, because in 19 lines of YAML, I have a backup strategy, which is really cool. So let's go ahead and run this. I'm going to say Benthos. I'll get rid of this template, and we'll just call this backups.yaml. All right. And this should theoretically be backing things up. Now, I could go to our AWS console and look that up, but I think it would actually be cooler to just go ahead and create a quick restore function here just to make sure that it's all working. So I'm going to go ahead and create another file called restore.yaml. And I'm going to paste this in. We're going to have AWS S3 as our input. Again, CodeGangsta backups. And this time we're going to use a scanner, just like we used with that CSV. But instead of a CSV, we're going to decompress it via the gzip algorithm, and we're going to untar it. And that's pretty much all that we need to do. So I'm going to go ahead and save this, and let's go ahead and run restore and see if we can get some messages back. So there we go. We're pulling all of these messages from S3 that are archived in tarred and gzipped. And that's one way to kind of restore in kind of a tiered storage situation. So that's pretty much it. I hope you guys got a lot of value out of some of these examples. I think Benthos plus NATS is just a really, really powerful combo to work with. And I hope this kind of inspires you to start playing with some ideas here. If you do like content like this and you want me to show even more examples, there are literally like so many things that I could cover between these two technologies. So feel free to sound off in the comments and let me know what kind of things, what kind of problems you might be facing at work in terms of shuffling data around, how to simplify it. And we can come up with some more videos on how to do some more data processing here. But that's about it for me. Thanks so much for watching, and I will see you in the next video.